question is identify the pairs which has different dimensions. Planck's constant, angular momentum, impulse and linear momentum, angular momentum and frequency, pressure and Young's modulus. So dimension wise, Planck's constant and angular momentum both have the same dimensions. Impulse and linear momentum, obviously they have same dimensions. Angular momentum and frequency, the angular momentum that is given by m momentum is omega, which is equals to mrv, and the frequency f, which is both the dimensions of this are m1, that is L2, and v raised to v, it will be t raised to minus 1, and the frequency you will have inverse of time, that is t raised to minus 1. So obviously these both pairs have the different dimensions, so this is the perfect pair. This is the pair. Pressure and Young modulus, yes, they do have the same dimensions. Now if the length of rod A is 3.25 plus minus 0.101 centimeters and that of rod B is 4.19 plus minus 0.101 centimeters, then the rod B is longer than rod A by. So rod B minus rod A, we have to find the B minus A length, that is 4.19 minus 3.25. So 4.19 minus 3.25 will give you 0.94, but the plus minus error you have to add it, so this 0.01 plus 0.01 will become 0.02. As a result, the option is 0.94 plus minus 0.02 centimeters. Okay. The next sum is the velocity time relation of an electron starting from rest is given as V is equals to kT, where k is equals to 2 meters per second square. Meters per second. The distance traveled by in the first 3 seconds is, so we have to find the distance traveled by this particle. The formula for distance is ut is equals to half at square, that you can use the kinematical equation, where its initial and velocity is 0. Okay, so from that it is starting from the rest, and that's why we get the u as 0. So if we place the values correctly, u is 0 into the time is, we are supposed to find the distance traveled in the first 3 seconds plus half the acceleration is given. The acceleration is nothing but the change in the velocity with respect to time, so that is given as 2 meters per second. So you can take this as 2 into time square is 3 ka square. So after solving this becomes 0, 2 1s are 2 1s are 3 square becomes 9 meters. So S is equals to 9 meters. A is the correct option. Okay. Next, question number 4. The height y and distance x along a horizontal plane of a projectile on a certain planet with no surrounding atmosphere are given by y is equals to 8t minus 6t square and x is equals to 60 meters, where t is in seconds. The velocity with which the projectile is projected is, so if there is a projectile like this along the xy axis, it goes like this. Okay, the equation of the projectile is given. They have said that the x is equals to 60. So for the x axis you have x is equals to u cos theta. Okay, and that u cos theta times you can find t. For the distance you have the velocity multiplied by time, and this entire thing is given as 6 out here. Okay, that means u cos theta becomes equals to 6. Okay, so we can just write it down. U cos theta becomes 6. Okay, and the rest equation is what we are going to use the equation of the projectile, that is y is equals to u sin theta t minus half gt square. Okay, according to this equation, u sin theta will be given by u sin theta is this along the y axis, y is equals to u t sin theta, that is 8. So 8 into t minus 5t square. Okay, so that, okay, the next sum, a body is moving with along a rough horizontal surface with an initial velocity 6 meters per second. If the body comes to rest after traveling 9 meters per meters, then the coefficient of sliding friction is, the coefficient of sliding friction mu is given by the formula mu is equals to u square upon 2as, that is equals to 2, you can say it as 2gs. So u is your initial velocity, which is given 6 meters per second, upon 2 into your a is nothing, acceleration due to gravity, that is 10, and the distance covered by the body is 9. So altogether we get 6 square, that is 36 upon 2 into 10 into 9. So there is say 2 1s are 2 9s are 2 8s are, and then this becomes 2 5 and 1s are 9 2s are 2, so that becomes 0.2. Okay, so the friction coefficient is 0.2. Next, seventh one, a block of mass A block is moving up with an inclined plane of inclination 60 degree with the velocity 20 meters per second. So there is an inclination of an angle 60 degree, okay, and there is a block of mass, and it is starting with the velocity 20. It is moving with velocity 20 meters per second, and it stops after 2 seconds. Okay, so here we can find the retardation, the deceleration of that particular particle, which is given by retardation is equals to g times sine theta plus mu cos theta. So that is what the theta is sine 60 plus mu times cos 60. Okay, so g times sine 60 is root 3 by 2 plus mu times cos 60 is half, and if you take this g as 10, it becomes 5 times root 3 plus mu. This is your retardation or deceleration, you can say. Now the approximation value of friction of coefficient of friction is given by, so the coefficient of friction mu will be given by the formula v is equals to u minus 80. This is v is equals to u minus 80. Why we are taking a minus? Because it is deceleration, and the final velocity obviously it is 0. The u has to be the initial velocity, that is why it is which is moving, that is 20, minus the acceleration just what we found 5 into bracket root 3 plus mu into t. Okay, so after solving this, you get the value of mu, that is the 5 goes the 5 root 3, the 5 goes in, and your time is given as, time is how much? It is 2 seconds. Okay, so 5 to 0 becomes 10, and this is 10. So your mu ka value comes out to be around 0.27. okay, so this is your C option, 0.27. Next, a bullet moving with a speed of 100 meters per second can just penetrate two planks of equal thickness. The number of such planks penetrated by the same bullet when the speed is doubled. Okay, so first we'll take the velocity ka equation. V is equals to u square minus 2as. Okay, V is equals to u square minus 2as. The reason why minus, because the bullet is going to come to rest. Okay, now the speed of the initial speed of the bullet is 100 meters, then it stops after covering a distance of a distance of 2 times s. So here if you take your final velocity as 0, you get u square is equals to minus 2as. That means your s, your distance has to be u square upon 2a. That means your distance and your velocity has a relation of distance is equals to the square of your velocity. That means if the speed of the bullet is doubled, then the bullet will cover 4 times the distance. Okay, so if you double the speed of the bullet, the 4 times of that double will give you 4 times into 2 distance, that is 4 2s are 8. So the planks, the bullet will penetrate 8 planks. Okay, next sum. There are 4 particles of mass m, 2m, 3m and 4m arranged in the corners of the parallelogram, which each side is equal to a. So this is your x-axis and this is your y-axis. Along this there is a parallelogram, and along each sides of a parallelogram there is mass. This is this m, there is 2m here, there is 3m here, there is 4m here. Okay, and at the corners of the parallelogram, which each side equal to a, so the sides are equal to a. So this is a, this is a, this is a, and this is also a. Okay, and one of the angle and the a equal to a, and one of the angle between the two adjacent sides is 60 degree. So this angle will be 60 degree. So this height has to be a sine 60 degree, right? Okay, the parallelogram lies in the xy plane with the mass m at the origin and 4m on the axis. So mass m is here and 4m is here. The center of mass of the arrangement will be, center of mass we need to find out. So center of mass formula is center of mass is given by r is equals to m1 r1 plus m2 r2 so as to m1 rn upon m1 plus m2 plus m3 so as to mn. Okay, so first we'll find out the r vector, because we have the masses, we need to find the r. So for r1, for the mass 1, r1 is equals to, it is at 0 0 position, so 0i plus 0j. And then for r2 we have is r2, we go to here, it is having a height, it is having an x-axis of a cos what is this? This is given, this is the sine theta, this is the cos theta, right? So a cos 60 degree, so this is a cos 60 degree along the y-axis, x-axis I cap, and along the y it is having a sine 60 j cap. Okay, then we find r3, where is r3? R3 is here, 3. Okay, so for r3 first we cover this distance, and then we have this rest of the a, so it becomes a plus a cos 60 Okay, I cap plus the j bar is again the height, that is a sine 60 j cap. And then we come to r4. R4 is along the x-axis only, the y-axis it will be 0, so it is nothing but ai plus 0 j bar. Now we add this and we divide it by the masses, that is m1 plus m2 plus m3, and all together we get the r bar equals to something 0.95 times a comma root 3 by 4 comma a. Okay, so these are the two values around the x and the y-axis. 0.95 a, 0.3 root 3 by 4 times a. This is the center of mass where it will be located. So your correct option here is B option. Okay, next, in an orbital motion the angular momentum vector is, so in the angular momentum vector of in an orbital motion the angular momentum will always be perpendicular to the orbital motion. Okay, so along the radius vector, no, the parallel to the linear momentum in orbital plane or perpendicular to orbital momentum, it will be always in motion perpendicular to the orbital motion, orbital plane. Next, the two particles of equal masses m go around a circle of radius r. So let's draw a circle. This is a circle of radius r. Okay, there are two particles, one is having small m, one is having a particle of mass m, capital M, and they are moving a circle of radius r under the action of the mutual gravitational attraction. The speed of each particle with respect to the centers of the mass. So we have to find the velocity of each particle with respect to the center of mass. The center of mass is given by, so the gravitational force, it actually provides the necessary centripetal force, right? So the gravitational force is given for the smaller particle in gm upon 2r, gm square upon 2r square, which is equals to again the centripetal force, that is mv square upon capital R. After you solve this, we get the velocity for the equation for this, that is equals to r gm square upon 2r square. The r gets cancelled, so what we get is gm square gm upon, okay, this is velocity square, right? So it is gm upon 2 times r. So what we get is, after we remove the root, it becomes gm upon root 2 r, and this is your 2r square, so this becomes 4r square, sorry. So it will become 4r, so gm upon 4r. A copper bar of length L and cross-section area A is placed in a chamber at atmospheric pressure. If the chamber is evacuated, the percentage change in its volume will be, compressibility of copper is 18 to 10 raised to minus 12, and 1 atmospheric pressure is 10 raised to 5 Newton per meter square. So the change in the volume is delta V upon V into 100. The delta V upon V will be the total change, that is the compressibility of the liquid multiplied by the 1 atmosphere. The 8 into 10 raised to minus 12 into 10 raised to 5 into 100. So 10 raised to minus 12 minus 5 is 10 raised to minus 7 into 100. That gives you 10 raised to minus 7, and this 2, that becomes 10 raised to minus 5. 8 into 10 raised to minus 5. So B is the correct option. Okay. The question number 13. A spherical ball falling through a viscous medium of negligible density has a terminal velocity v. Another ball of the same mass but of twice radius that of the earlier one falling through the same viscous medium will have the terminal velocity what? So terminal velocity is given by this 2 by 9 r square rho minus sigma g upon eta, but this particular thing has a negligible density. So negligible density, we can neglect this rho part, sigma part, hence you get the equation 2 by 9 r square rho g upon eta, where rho is the density of the liquid. Density is given by the formula mass upon volume, where the volume of the sphere will be 4 by 3 pi r cube. So it will be 2 by 9, nothing 2 by 9 r square m upon 4 by 3 pi r cube g. So here r square and here this cube gets cancelled. That means your velocity is inversely proportional to your radius. Okay, now suppose you have another mass whose radius is twice. So that means v is equals to 1 upon 2 times r. Okay, so it is inversely proportional. So that's why if your velocity is inversely proportional to your radius, that means your velocity will be reduced by half. So your C will be your correct option. Okay. There is a wooden block of density rho. It is immersed in a water of density rho naught to depth h, then released. The height h above the surface of water up to which the ball jumps out of the water is. So firstly, that is a wooden block. It is been immersed in the water. The water is having density rho. So and after releasing the wooden ball will go up with a certain acceleration, and that acceleration will be given by the upward thrust minus weight of the ball and divided by mass of the ball. Okay, where you can calculate this in terms of V rho naught g minus V rho g upon V, the density, the mass will be density upon volume. So this is V rho. Okay, mass will be density into volume, so the V into rho. Now if you take the VV common here, you get rho naught minus rho upon rho g. This is your acceleration. Okay, now suppose the ball goes up with the velocity v. Okay, so with the velocity v, its equation becomes v is equals to under root 2gh, which becomes 2as. Okay, so this is 2 times a is nothing but this entire part, so rho minus rho upon rho g into s is your displacement, but that s is here nothing but your height, so that is equals to height. Okay, so this is your h. Now again this particular part, now again this ball with suppose it covers a vertical distance of height h, so your h is nothing but v square upon 2g. Okay, so your v square, you have to square this equation, that becomes 2 rho naught minus rho upon rho g into h upon the entire term becomes 2 times g. Okay, so this is 2 times g, and if you solve this entire equation, you will get rho naught minus rho upon rho into h, and this gg gets cancelled, so this is nothing but rho naught upon rho. Okay, so the height up to which the ball will jump is given by rho naught upon rho, so that is option number rho naught upon rho. This you keep it constant, so it is rho naught upon rho minus 1, so it is rho naught upon rho minus 1, so it is option number D, rho naught upon rho minus 1. Okay, next sum. A black body emits radiation of maximum intensity at wavelength 5000 angstroms. Okay, so it emits the wavelength at 5000 angstroms when the temperature of the body is 1227 degrees Celsius. If the temperature of the body is increased to 2227 degrees Celsius, the maximum intensity of emitted radiations will be observed at. So the maximum radiation, so here we have this particular relation of wavelength with respect to temperature, that is delta 1 upon delta 2 is equals to T2 upon T1. So instead we can have delta 2 is equals to T1 upon T2 times 10 delta lambda 1. Okay, so T1 upon T2 is nothing but T1, the initial temperature is how much? It is both the temperatures are given as around, and the wavelength is how much? 5000 angstroms, so you can multiply this by 5000 into T1 upon T2. T1 is given as 1227 degrees Celsius, that is how much Kelvin? It is 1227 plus 273, that is 0.01500 Kelvin. 1500 divided by, this is 2227 plus 273, that is around 073, that is again 2500, so 2500 Kelvin into this lambda 1, that is 5000. If you solve this, you get a wavelength of 3000 angstroms. Okay, so this your correct option is B. Next is the question number 16. It states that the CV is equals to 4.96 calorie per mole, and then the increase in the internal energy when the temperature of 2 moles of this gas is increased from 340 Kelvin to 240 Kelvin. So the change in the internal energy delta U is given by mu times CV delta T. Okay, so your mu is given as, it has to be increased 2 moles, so 2 into CV, that is equals to how much? 4.96 into the change in the temperature is 342, that is again 342 minus 340. Okay, after solving this, you will get a value of 19.84 calories. Okay, so that is your correct option. The formula is this: the change in the internal energy with respect to time will give you mu CV at constant volume. Next, 17. 100 gram of water is heated from 30 degree to 50 degrees Celsius. Ignoring the slight expansion of water, the change in its internal energy is, so the change in the internal energy of the water is given by Again there delta U is equals to mc delta T, the mass into the specific heat C into the change in the temperature. So the mass of the water is how much? 100 grams is given, that is into 10 raised to minus 3 into the specific heat of water is how much? 4184 into the change in the temperature is 50 degree to 30 degree, that is 20 degree of difference is it. If you solve this you will get a value of 84 kilojoule, that is the change in the internal energy. So 84 kilojoule is the perfect answer. Okay, next is the question. It is root mean square speed of a molecule of ideal gas is mu. If the pressure is increased 2 times at the constant temperature, the RMS speed will be. So the root mean square speed of a molecule, of this gas molecule, it doesn't depend on the pressure. Okay, if the temperature remains the constant, then it won't depend on the pressure of the gas. Now if the pressure is increased n times, the density will also increase, and by n times, and hence the velocity will remain the constant. Okay, so your answer option will be V. If there is a gas which is having root mean square velocity V, though you increase the pressure, the root mean square velocity will not increase, it will remain V. Okay. The motion of a particle varies with time according to the relation y is equals to a sin omega t plus b cos omega t. Y is equals to a sin omega t plus b cos omega t. The motion is oscillatory but not SHM. The motion is SHM with amplitude a plus b. The motion is SHM with amplitude a square plus b square, and the motion is SHM with amplitude a plus b, a square plus b square, the whole under root. So we need to find the amplitude for that. So let's see. First we take that a is equals to, let us assume that a is equals to r sin theta. We can take it as r cos theta, and here your b can be taken as r sin theta. Okay, so your equation becomes r cos theta a sin omega t plus r sin theta cos omega t. Sorry, this will go. Okay, next is this entire thing. If you solve it, you will get it equal to r sin omega t plus theta. Okay, that means your a square plus b square. If you do this a square plus b square, you get that r square into bracket r square sin square theta plus cos square theta. Okay, that is equals to 1, that is equals to r square, that is a square plus b square. So your r is nothing but under root a square plus b square. So your option number 4, it is in SHM with the amplitude r becomes equals to under root a square plus b square. Okay, a spherical condenser, a source and an observer approaches each other with the same velocity, that is 50 meters per second. That means the velocity of the source, velocity of the observer and the velocity of the source is the same, 50 meters per second. If apparent frequency, that is NA, is equals to 435 meters per second, then that is hertz, then the real frequency is, okay, so the real frequency n is you have to find, and you have the option as Na is equals to n into V plus V naught upon V minus Vs. Okay, this is when the source and the observers approach each other with the same velocity. That means both are approaching towards each other. So your n is nothing but this is your n which you are supposed to find. N is equals to 435, which is equals to n times V, that you are going to take the velocity of light. You can take it 332 plus velocity of the observer 50 upon 332 minus velocity of the source, that is 50, and you get the value n to be around 320 per second. Okay, so the correct option is A, 320 per second. Next is the spherical condenser has inner and outer surfaces of radii A and B respectively. The space between the two is filled with air. The difference between the capacities of the two condensers formed when outer space is earth, when the inner space is earth will be. Okay, so there are two conditions here: the capacitance of the condenser when the outer space is sphere is earth, and when the inner sphere is earth. So when the outer sphere is earth, your capacity becomes C1, which is equals to 4 pi epsilon naught AB upon B minus A, and when the inner sphere is earth, then the equation becomes 4 pi epsilon naught B plus 4 pi epsilon naught AB upon B minus A. Now you have to find the difference in between them. So therefore you do C2 minus C1. After you minus this, you get this 4 pi epsilon naught as common and the inner part becomes cancelled, so you get only 4 pi epsilon naught b as the answer. So C is the correct option. Okay. Next is 23rd sum. The metallic rod sphere is placed in a uniform electric field. The lines of the force follow the path shown in the figure as. So the lines of the force, okay. The metallic solid sphere is placed in uniform electric. The lines of forces follow the path as shown in the figure as. So how many lines of forces are following the path? It's actually that the electric field is always perpendicular to the surface of the conductor and the field lines. Okay, and the surface of this conductor and the field lines will never cross the conducting surface. So that's why if there are 4 lines which are passing, so all of the 4 they will pass, they will never cross the conducting surface. So the option is 4. Okay, next. Two electroplating cells, one of silver, another of aluminum, are connected in series. The ratio of the number of silver atoms to that of the aluminum atoms deposited during the time t will be. So the number of ions which are be deposited, which will be deposited during the time will be in an electrolytic cell. So that will be nothing but it will be given by a formula. So number of ions liberated is equals to current into time upon E into the valency. Okay, so this number of atoms is inversely proportional to the valency P. Okay, so if you take a ratio, that is Na for the one is of cell and silver and another is of aluminium. So if you take it as silver upon aluminium, you get it that P of aluminium upon P of silver. Okay, so what is the P of aluminum upon silver is nothing but the aluminum has 3 upon 1 is the ratio for the valency of silver with respect to aluminum with respect to silver. Okay, so the 1 of silver, the connected the ratio of the number of silver atoms to that of the aluminum atoms will be 3 upon 1. So 3:1 should be the answer. It's B. Okay. Two identical heaters of 220 volts 1000 watts are placed in parallel with each other across 220 volt line, then the combined power is. So if you have two resistances connected in parallel, you get 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on, where your voltage with respect to power and resistance is R is equals to V square upon P. So instead of R you can put V square upon P, you get P upon V square, P1 upon V2 square, P2 upon V2 square. Okay, so that means your power is in series, so P is equals to P1 plus P2. So there are two resistances, there are two heaters, each of them has a power of 1000 watts. So P1 plus P2 is 1000 plus 1000, that gives you 2000 watts. So this is your answer. Okay. Okay. So there are two bars of radius R and 2R are kept in contact as shown. An electric current is I is passed through the bars, whichever the one is following is correct. So there are two bars of radius small r, and there is another bar of radius 2 times r. Okay, so then electric current is passing through the bar, which of the following is correct. So when there is an electric current, there is a heat generated. Heat is equals to heat produced in the bar BC is 4 times the heat produced in bar AB. Heat electric field in both the halves is equal. Potential difference across AB is 4 times that of BC. Current density across AB is double that of BC. So current electric field in both halves is equal, that is false. The current density AB is double that of BC. No, the current density can't be doubled. The potential difference across AB is 4 times that of BC. No. Now your heat generated is I square RT. That means your heat with respect to the resistance is H of AB upon H of BC is equals to resistance of AB upon resistance of BC, right? So the resistance of AB is nothing but the resistance of AB is nothing but 1 upon 2R, and the resistance of BC is nothing but 1 upon R. So here if you the resistance with respect to the current and the small r, it can be inversely proportional to R square. So if you use this R square here, your H of AB upon H of BC is nothing but 1 upon 2R the whole square upon 1 upon R the whole square. Okay, after solving this, your RR gets cancelled, you get a ratio of 1 upon 4R. Okay, so that means your H of BC is nothing but 4 times H of AB. That means your heat producing bar BC is 4 times the heat producing bar AB. Okay. A moving coil calculator gives a full scale deflection when the current of I 0.005 is passed through it. So it is galvanometer 0.005. It is converted into a voltmeter reading. Volt is it is converted to voltmeter reading up to 5 volts. Okay, and voltmeter reading up to 5 volts, and by using an external resistance 975 ohms. So the external resistance R is how much? 975 ohms. Okay, now what is the resistance of the galvanometer? So resistance of the galvanometer is capital G, which is equals to V upon Ig minus cap minus R. So that is V is how much? 5 upon Ig is how much? 0.005 minus 975 will give you a value of 25 ohms is the resistance of the galvanometer. So this is 25 ohms. Okay, sum number 29. The loop of the area A is equals to 0.5 meter square placed in a magnetic field B whose power is about 2 Tesla and in the direction making angle theta how much? 30 degree with the field. The magnetic flux, that is phi, is how much? That is phi is given by B into A cos theta, that is equals to B, that is 2 into A, that is 0.5 into cos of 30, that gives you root 3 by 2. So the answer is root 3 by 2 Weber. Okay, B. Next, on applying an external magnetic field to a ferromagnetic domains, aligns in the direction of the magnet, aligns in the direction opposite to the magnetic field, remains unaffected, or none of the above. On applying magnetic field to the domains of a ferromagnetic substance, the domains of the ferromagnetic substance, they try to align themselves in the direction of the magnetic field. Okay, so they align themselves in the direction of the magnetic field. 31. The self-induced EMF in a coil of 0.4 Henry self-inductance when the current in is changing at rate of 50 amperes per second is. So the EMF induced is L for self-inductance is L di by dt. So the self-inductance is given as 0.4 Henry into the change in the current is 50 amperes per second. So that gives you a value of 200 volts. So the correct answer is so that gives a value of 20 volts. So the correct option is C, it's 20 volts. The option was wrong here. Okay, next the sum is, what is the RMS value of an alternating current which when passed through a resistor produces a heat which is thrice that of the produced by a direct current of 2 ampere in the same resistance. So the heat produced by an alternating current to the heat produced by a direct current, that the heat produced by an alternating current is IH is equals to you can do this I square RT. Okay, so for you can take this twice, for the one for the alternating current, another for the direct current. So for the alternating current they say it is I square RMS RT, which is equals to 3 times I square RMS RT. So the RT will get cancelled and I square is equals to 3 times into your current is given 2 amperes in DC, so 2 square, that becomes I square is equals to 2 root 3, that is your I will be equals to 2 times root 3, so root 3 is 1.702 into 2, that becomes 3.46 amperes of the current. Okay, so C is the correct option. In a pure inductive circuit or in an AC circuit containing inductance only, the current leads the EMF by 90, lags the EMF by 90, or sometimes lead or sometimes lag behind the EMF, is in phase with the EMF. So in an inductive circuit where you have an inductor connected, okay, and in an AC circuit, the current I will always lag behind with the V. So your current I will be having the equation I is equals to I0 sine omega t minus pi by 2. Okay, so it will be always lagging behind with the EMF by an angle of 90 degree. The sun delivers 1000 volt per meter square of electromagnetic flux on the Earth's surface. The total power that is incident on the roof of the dimension 6 meter by 30 meter is. So the intensity is given 10 raised to 3 watt per meter square, and the total power is asked for the area, which is equals to 6 into 30, that is 180 meters square. Okay, so the power is I into the intensity into area. Intensity is 10 raised to 3 into 180, that gives you 1.8 into 10 raised to 5 watt of power is there. So A is your correct option. Okay, the graph shows the magnification M produced by convex lens varies with the image distance V. What is the focal length of the line used? So for a lens the magnification is given as focus minus objective image distance upon f. So that can be 1 minus v upon f, that can be written minus v upon f is equals to plus 1. So if we write this in terms of y is equals to mx plus c, then this will become, it will be 1 upon f into v plus 1. So your m is nothing but minus 1 upon f here. Okay, this is your slope then, and for this particular graph the slope becomes, slope is how much? It is b by a. So that means your b by is nothing but minus 1 upon f. So your f is nothing but your slope is how much? B by c, b by c. So your b by c is nothing but equals to minus 1 upon f. So your f is nothing but c upon b. That is your slope, that is D option. Next, 36. There is a vessel of depth 2d centimeters and is half filled with liquid of refractive index mu1, and the upper half of the liquid, with the liquid of refractive index mu2. The apparent depth of the vessel seen perpendicularly is, so the apparent depth, that is the height dash, is equals to the distance depth d1 upon refractive index mu1 plus depth d2 upon refractive index mu2, which is equals to d times, okay, because the depth is the same, the entire vessel, so d becomes equals to 1 upon mu1 plus 1 upon mu2. This will be the apparent depth. So that is option number B. Okay. Next, through a quantum theory of light, we can explain a number of phenomena observed with light. It is necessary to retain the wave nature of light to explain the phenomena of photoelectric effect, diffraction, Compton effect, black body radiation. So the wave nature of light can be explained by the phenomena like diffraction. For example, the light passing from the edge of a surface and then getting diffracted. This gives you the wave nature of how the light behaves. Okay, so the photoelectric effect will give you the behavior of a particle of that particular light. Compton effect will give you the same, and the black body will give you the radiation. To understand how the wave behaves, you need to find out the diffraction, understand the diffraction phenomena. Okay, so four particles have the same momentum. Okay, which of the following here has the maximum kinetic energy? So which of the following has maximum kinetic energy? Proton, electron, deuteron, or alpha particle? See, the kinetic energy with respect to momentum is given up by p square upon 2m. Okay, so that means if the momentum is same, that means the of the four particles the momentum is same. So that means the kinetic energy will be maximum if the mass of the particular particle is minimum. Okay, out of this the mass of electron is minimum, as a result its kinetic energy will be maximum. Okay. K alpha and K beta X-rays are emitted when there is a transition of the electron between the levels. Okay, so K alpha and K beta X-rays, basically these are the X-rays which are generated when an electron, it strikes or it removes the electron from the K shell, okay, of an atom. And if or some of the other electron, if it jumps from the higher shell to the K shell to fill up the K shell, then then it is said to be an K alpha or K beta X-rays generated. Okay, so K alpha and K beta X-rays are emitted when there is a transmission of electron between the levels, that is n from equal to 2 to n equals to 1, or from n equals to 3 to n equals to 1. Okay, so from 2 to 1 or 3 to 1. So the correct option is first, n equals to 2 to n equals to 1, or n equals to 3 to n equals to 1. Okay. Next, the ratio of minimum wavelength of Lyman and Balmer series is. So for the minimum wavelength of Lyman series, first for Lyman series, we have this 1 upon lambda, which is equals to r times 1 upon the starting, that is 1, minus 1 upon the final, that is infinity, which is equals to this 0, that becomes r. So your lambda becomes inversely proportional to r, and according to your r you get the value of 912 angstroms. Same way for Balmer series, your minimum wavelength is 1 upon lambda, which is equals to r times 1 upon, this is second square, minus 1 upon infinity square. Okay, that is again r by 2. So that is again 2 square, so that becomes lambda becomes equals to 4 upon r, that is nothing but 3636 angstroms. So in order to find the ratio of that, divide this particular two particular things, that is 3636 divided by Lyman 912 divided by 3636, that will give you a value of 0.25. okay, now what will be the ratio of the radii of Li7 nucleus to the Fe56 nucleus? So the radius we have r, given the formula r naught a raised to 1 by 3, it is nothing but the proportional to the a raised to 1 by 3. So r1 upon r2 if you do, that means a upon a raised to 1 by 3. Then first a is given 7 upon 56, so 7 upon 56 raised to 1 by 3, that will give you a value of 1 by 2. So 1:2 is the ratio. Okay. When a radioactive isotopes 88R228 decays in the series by emission of 3 alpha particles and beta particles, the isotope finally formed is. So for the atom, for the mass number, A will be equals to for the mass number, the A will be equals to the total number of particles, that is 3 alpha and beta. So that will be 3 into the total, that is it is multiplied by 4. So therefore these are the 12 particles which are getting decayed. And in the atomic number, it is having 3 into 2 minus 1, so that becomes again 5Z. So your atomic number 228, your mass number 228 decreases by 12, so it becomes 228 minus 212, that is becoming 216, and your mass number, atomic mass number, it decreases by 88 minus 5, that gives you 83. So your x has to be having 216 and 83. Okay. Next sum, a truth table is given. Which of the following has this type of truth table? So this is a truth table of NOR gate, because it is the complement of OR. So for example, it is nothing but y is equals to a plus b the whole mod complement. So if you add 0 plus 0, you will get 0. Mod of that, complement of that is 1. 1 plus 0, 1, and complement of is 0. 0 plus 1 is 1, complement of that is 0. 1 plus 1 becomes 1, and the complement of that is again 0. So it's a NOR gate. Okay. Next, a carrier wave is modulated by a number of sine waves with modulation indices m1, m2, m2. The total modulation index m will be. So the total modulation index m of a sine wave is given by under root m1 square plus m2 square plus m3 square and so on. Okay. So the correct option is C. Okay. Next, an antenna is a device that converts electromagnetic energy into radio frequency signals, that converts radio frequency signals into electromagnetic energy, that converts guided electromagnetic waves into free space electromagnetic waves, and vice versa. None of these. An antenna is basically a metallic structure, and it is used to radiate or used to receive the electromagnetic waves. Okay, so it converts the guided electromagnetic waves into free space electromagnetic waves and vice versa. So C is the correct option. Okay, next. The height y and the distance x along the horizontal plane of the projectile of a certain planet with no surrounding atmosphere are given by y is equals to 8t minus 5t square and x is equals to 60 meters, where t is in seconds. The velocity with which the projectile is projected is. So the equation given is x is equals to 60, but we have the x along the x-axis is x is equals to u cos theta t, that is equals to 6. That means your u cos theta becomes equals to 6. Again you have the equation along the y-axis, that is y is equals to u sin theta t minus half gt square. If you compare it this with this equation, then you get your u sin theta t equals to 8. Okay, now you are supposed to find the total velocity with which it is projected, u. The total velocity will be given by under root ux cos theta cos square theta, ux square cos square theta plus uy square sin square theta. Okay, now if you take both of them as 6 and 8, here cos and 6, so it will become 6 square plus 8 square, that will be nothing but 36 plus 64, that is nothing but 100, and root comes out, that becomes 10. So B is the correct option. Now in the above equation, if the angular velocity is kept same but the radius of the path is halved, the new force will be. Now the force with respect to the angular velocity is given as force is equals to m omega square r. That is, this force is directly proportional to your r. Okay, so if your radius is halved, then your force will also be halved. Okay, so it will become f by 2. C is the correct option. Okay. There are two insulating plates and are both uniformly charged in such a way that the potential difference between them is V2 minus V1 is equal to 20 volts. That plate 2 is kept at higher potential. The plates are separated by a distance d which is equal to 0.1 meters and can be treated as infinitely large. An electron is released from the rest on the inner surface of the plate 1. What is the speed of it when it hits the plate 2? So there are two plates given, plate number 1 and plate number 2. Obviously the voltage across plate 2 is greater than the voltage across plate 1, so the electron will experience a full electrostatic electric force and the opposite opposite to the direction of the electric field, and hence it will move towards the plate 2. Okay, so we are supposed to find what is the velocity of the plate of this electron when it hits the plate 2. So we'll use the work energy theorem, that is MEV square, half ME square minus 0 is equals to E V2 minus V1. Okay, so therefore again the mass Me of the electron, mass of the electron is given again 9.11 into 10 raised to minus 31 upon the V, that is we are supposed to find out the velocity, into 2 minus E, that is equals to E charge on electron 1.6 into 10 raised to minus 19 into V2 minus V1, that is the voltage across both of them is 20 volts. Okay, so V square will be equals to nothing but 2 into 1.6 into 10 raised to minus 19 into 20 divided by 9.11 into 10 raised to minus 31. Okay, after solving this you get the value of V to be around 2.65 into 10 raised to 6 meters per second. That is your correct option number A.